Welcome back, learners. In the previous session, we have discussed about obtaining the beam results, right? So now, before we start the design of the beams, so we are supposed to have some basic grouping knowledge while especially doing the design of the beams. Before that, in order to do that, first let me do what I'll do is I'll set the building limits. That means I wanted to show all the buildings now, so therefore I have kept the view limits as all. Okay, so I want to show all the members, right? Yes. So now according to this, you can see here, since this is the topmost floor, whatever the load that you are going to have on these beams are comparatively lesser compared to this first floor, and compared to this first and second, whatever the loads that the plinth beam is going to experience is again less, because the plinth beam are placed only to have the stiffness, increase the stiffness of the column, but it will not take much of the load. No loads from the columns will be transferred to the plinth beams. The plinth beam will transfer only the loads, that is the wall loads which is present on that beam, because this will be the ground level. So on this the wall will be constructed, whatever the wall load is there, only that load will be transferred to this plinth beam, and from the plinth beam it will be transferred to the column. Okay, so the main two reasons that why plinth beam we are providing, the first and the foremost reason is in order to make the slenderness ratio of the column lower, thereby making the column stiffer. Okay, and even not only that, the entire structure also becomes more and more stiffer. And anyhow, in order to have a support to construct the walls, the plinth beams are provided. Therefore, usually the dimensions of the plinth beam is also small, as well as the reinforcement provided to the plinth beam is also small, right? Yes. Now, therefore, if you see the Excel sheet, okay, if you see the Excel sheet, so the top story will be the one which is having the lowest shear force as well as the lowest positive and bending moment values. You can see that if I take beam 4, these are the corresponding shear, positive and negative bending moment. The same beam which is provided below in the below story, whereas you can see it is 91, 117 and 122. That much amount of the loads and shears or the moments has been increased in the beam. Again, when you come to the plinth beam with the same beam, you can see again it is reduced. Okay, because it is resting on the soil, therefore not much of the moments will be induced. Now, before we start doing the grouping, you can see that by looking into this, we have an option to do the grouping. Okay, so what we will do is we will try to do in such a way that we will make some sets of groups and we will design it. Definitely, while designing any of these beams here, we are going to design it as either the fixed beam or the continuous beam. So let us learn that whether we are going to do the beam design as a fixed beam or the continuous beam later. But anyhow, we will not be doing it as a simply supported beam, that is 100% sure. Either it will be designed as a fixed beam or it will be designed as a continuous beam. But before we do that, we are supposed to do the grouping of the shear forces and negative and positive bending moments. But keep it in mind, students, when we start doing the grouping, when we have more and more number of groupings, it is very difficult in the practical side to execute it. I'll tell you the reason why. Now let me go to the top story. Okay, let me go to the top story. Right now, if I take here itself, if I take the top story, now what I wanted to say is, you can see here that okay, we have a particular beam here. Okay, we have a particular beam. Okay, so for that particular beam, you will be having one shear force, you will be having one positive bending moment, and you will be having one negative bending moment. Okay, now what we will do is then later we will go to the Excel sheet design. We will design it as per the fixed beam, or we will go for the continuous beam. We will design, and after designing we will get how many number of reinforcement is required both at the top as well as at the bottom, as well as the stirrup spacing, everything we will get. Okay, now let us go to this beam. Now we will design this beam. So for that particular shear force, for that particular bending moment, and for that particular positive as well negative, you will get some reinforcement detail. Next to that there is another beam, and next to that again there is another beam. So for this beam 11 also we will be having some corresponding shear force bending moment, as well as for this beam 14 also it will be having some corresponding shear force and bending moment. So when we develop the Excel sheet and when we put the corresponding beam 10, beam 11 and beam 14 bending moment and shear force, correspondingly you will get the number of reinforcements. If in case the reinforcement number for beam 10, beam 11 and beam 14, if they are different, okay, if they are different, then theoretically as per our design it is correct, but practically it is very difficult. For example, here you are getting 3 numbers of some diameter to the bottom, here you are getting 4 numbers of some diameter to the bottom, here you are getting 2 numbers of some diameter to the bottom, then practically it will take a lot of time, as well as it will create a very huge wastage of the reinforcement. Okay, very huge wastage of reinforcements in these beams, because even though the diameters may be different as well as the numbers will be different, then calculating the total quantity of steel required as well as executing that in the site is very difficult. Okay, that's why while doing the grouping we have to keep in such a way that if we are providing some reinforcement, try to provide that reinforcement throughout the length. Okay, not to the entire floor I'm telling, at least to a entire one stretch of columns, one stretch of beams, you're supposed to provide that continuous reinforcement so that it will be easy for us to execute in the site. So by keeping that in the concept, now let us start doing the grouping. So now I am in the story 2. Okay, let us complete the grouping of the story 2. Now when I go to the story 2, now I am in the story 2. So therefore let me go to the story 2 now. Now in that you can see that if you go to this, you have beam 43 and beam 44. Definitely while executing in the site, so they will, any contractors or any worker will provide this reinforcement continuously in this beam 43 and beam 44. Okay, so therefore let us see that out of beam 43 and 44, whichever is of highest shear force and bending moment, and corresponding we will choose that. Okay, so beam 43 and beam 44, if you check, okay, you have where is beam 43, we will see here that yeah, you can see that beam 43 and beam 44. Okay, so let me give this as beam 43 comma 44, we will make one group. Okay, if you see beam 43 and beam 44, out of this the highest will be this 50. Okay, and this will be the highest negative moment, this will be the highest positive moment. Therefore I can choose these 3 and I will provide here. Okay, and you can remove all the negative signs. So negative signs indicates means just the opposite. Therefore I can keep like this. So therefore beam 43 and 44, it is over. Okay, I can provide the reinforcement in one stretch. Now when it comes to your beam 8, definitely you cannot have any continuous beam here, only individually you are supposed to provide beam 8. Okay, beam 4 and beam 6 we will see together, but beam 8 let us see what will happen. So beam 8, yeah, you can see that beam 8 individually itself you are supposed to provide, so no other option. Okay, so therefore I can provide beam 8 here. Okay, yeah, so beam 8 here. Okay, yes, so the next you can see beam 4 and beam 6. Okay, so beam 4 and beam 6 you can see, so this is beam 4 and this is beam 6. You can see 8 7.3, then 22 16, then 7 8. So you can see that almost this is higher, so therefore I can group this as beam 4 comma 6. Okay, therefore I can provide these two here. Okay, I can provide these two here, and this is highest, so therefore I can provide here. Okay, and I'll remove all the negative values. Yeah, so therefore your beam 4 as well as beam 6 is done. Okay, yes. So then if you come to this one, first let us complete all my horizontal beams. You can see beam 10, beam 11 and beam 14 together we will do beam 10, 11 and 14. Okay, you can see that the highest will be of this 19 and positive will be of this 9. So therefore I can provide beam 10, 11 and 14. So beam 10, 11, 14. Okay, so out of this, the highest will be the shear will be highest is 10. Okay, and this will be highest, that is negative bending moment, and 10, 11, 14, the highest will be this 9. Okay, yes. So beam 10, 11 and 14, right? Okay, so the next one after that, you can see that you can have beam 17 and beam 19. Beam 17 and 19, you can see obviously this will be the highest, beam 17 and 19, beam 17, 19. Okay, so beam 17 and 19. So then again beam 26 and 27. Okay, as well as this there is in one more beam 26, 27 and 30. Yeah, one more is 30 here, so I can go to this 26, this will be the highest one, so therefore I can provide this beam 26, 27, 30. Okay, beam 26, 27, 30. So the next one that you can have here, beam 32. Okay, so beam 32, beam 32. Okay, so then after beam 32 you can see beam 34, 39 and 37. Is it possible to do together? 34, 39 and 37. Okay, so 34, 34, 39, 39 and you have 37. Okay, you can see that out of these three you can see that highest one it will be of 39. Yeah, you can provide that, it will be of 39. Okay, and even the dimensions are also almost the same, right? So therefore I can give it for that. Okay, yes, you can provide these three. Okay, yes, so that is about 34, 39 and 37. So with respect to horizontal, all beams are completed. So now let us start with the vertical. So when I start with the vertical, you can see that if possible try to provide 21, 9 and 40. 21, 9 and 40. Okay, so 21, 9 and 40, and you can see here the 40 is a cantilever beam, so therefore definitely whatever the reinforcement that you have for the beam 9, the same reinforcement will be continued further. Okay, so therefore let us take 21, 9 and 40. Okay, so 21, 21, 40, 21 and 9. I told you that according to this, whatever B9 is there, same will be provided to 40. Okay, so now if I reduce the size, you can easily able to compare. Yeah, so now you can see that B40 it is 62, 34, 41. Okay, so definitely B40 is highest, and 268, 81, 98, again B40 is highest, so 7, 37, 46. So in that B9 is highest. In respect to positive one, B9 is highest. Okay, so therefore let us provide that. So these two, okay, so these two will be this, and the positive moment will be this one, what is 46. The same thing will be provided to the reinforcement at the top. So therefore I can write beam 40, 21 and 9. I can provide like this. Okay, and I don't want any fill here, so no fill. So in the same manner on the other side also you can have 20, 15, 5 and 42, and definitely whatever B5 is there, that same thing will be continued to 42. So 20, 15, okay, so 20, 15, okay, so 20, 15, 5 and 42. So 42 is here, 42, 5. So if you see these things, so which one I have to suppose to consider? See now 28, 31, 21, 20, that means 31, that is B20, which is B20. Yeah, B20 is this one, so that will be with the highest shear force. Then 70, 64, 34, this 70 will be provided, whereas positive the highest will be of the 34 of 20. 20 means okay, so 20, so 20 means that one, same thing will be provided till here. Okay, so therefore I can provide these two for these two, and the highest will be of 34, that will be the negative reinforcement. Therefore I can provide B 42, 20, 15 and 5. Okay, so like this I can provide the reinforcements, and you know, I don't want any fill here. Okay, yes. Okay, yes. So therefore we have completed these beams also, vertical beams. right? So now individually you can see that you have a beam 22 and 16, so that we cannot do. So let us go to the beam 16 now first. So beam 16, this I have to do it individually, therefore I am providing beam 16. Then beam 16, and the next one you have is beam 22. Okay, so beam 22 also we have to do individually. So beam 22, okay, so beam 22, okay, so beam 22, beam 16 and beam 22. Okay, now you can see that beam 7 and beam 41 will be there. So whatever you provide for 7, same thing will be continued to 14. So beam 7 and 41. So beam 7 here and 41 here. You can see that 89 and 18, definitely it will be 89, 242 and 52, and that will be 4. So therefore these two things, okay, and this will be the positive one. The same thing will be continued to continuous beam also. So I can go to beam 7 and what is the value, beam 7 and 41. Yeah, beam 7 and 41. Beam 7 and 41. Okay, yes. So then the next one, yes, definitely when it comes to these two, 23 and 25 we have to do together. 23 and 25. Okay, 23 and 25, you can see that out of this the highest will be these two, that is here. Okay, so then the highest will be 115. So this one, so beam 23, 25. Okay, beam 23 and 25, these two. So the next one will be, you can see that you can go to beam 28, 33, 45. Okay, beam 28, 33, 45, beam 28, 33, 45, beam 28. Okay, so beam 28, then 33, then 45. Right, if you see here, so out of these two the highest will be here only. Okay, so beam 28, 33 and 45. So the highest will be of these two will be 30. Okay, then the negative bending moment will be 38, 43 and 92. Definitely it will be 92, and the positive moment will be 23 is there, so it is 23. So therefore I can write beam 28. Okay, so beam 28, 33 and 45. Okay, so that is this one, beam 28, 33, 45. Okay, so then similarly I can go to 49, 35, 46, 49, 35, 46. So 49. Okay, so 49, 35, 46. 49, 35, 46. Sorry, 35 and 46. Again, in that you can see that the 30 will be highest one. I can provide here, and out of these two, 92 will be highest. I can provide here, and out of the positive one, definitely 22 will be highest. I will provide here. Okay, so therefore I can go to beam 35, 46, 49, right? Yes, so these are the three beams. Okay, yes, so the next one will be, you can have 31, 36, 48. Okay, so 31, 36, 48, 31, 36, 48. You can see 31, 36 and 48. Again, out of these three, the highest will be 52. Okay, then minus 100, then the positive will be 57. Therefore I can have beam 31, 36, 48. Okay, yes. Okay, yes, so then last you have these two beams here, 38 and 47. You can see 38 and 47. Out of these two, the highest will be these two. Yes, these three things will be the highest, so I can keep it here. Beam 38, 47. Okay, and you have left with beam 32, so which is that beam? Yeah, so it is an horizontal beam 32. Definitely it has to be individually it is done, so beam 32 we will do it individually. Okay, yes, so these are the groupings that we are supposed to do for the story 1, sorry, story 2. So let us see how the grouping is required in the story 1 in the next video. So after that, let us do for the plinth beam, and then we will go to the design. Okay, I hope you understood that how you are supposed to do the grouping, right? Thank you, learners.